Alright, so for chapter 2 problems, the first one of the extra problems was number 19, which is to draw bond line structures for all constitutional isomers of C5H12. So if you were to draw them out in Lewis structure form, that would be drawing it in this manner. All of the carbons out with the associated hydrogens, but now we're going to draw them out in the zigzag form. So this would be C5H12. That's one isomer, the straight 5 carbons across. So these two are the equivalent. Another isomer that I can draw will have 4 carbon chain, and then I can move one of the carbons there. And then I can have a 3 carbon chain with 2 carbons coming off of the second one. So that would be the 3 isomers. If you were to draw this 4 carbon chain with the carbon here, these two are the same. Or if you drew this one, these two are also the same. So all you've done is switch the position of that carbon group on the end there, but it's just a rotational isomer. If we bumped it up to C7H16, we're going to get actually a lot more isomers. Okay, so there's the straight across. And then I can do one with 6 carbons and put a methyl group there, or a CH3 there. This would be a different structure than this second one because the carbon's coming off of carbon 2. Here it's coming off of carbon 3. If I made one where it was coming off of carbon 4, that one is the same as the carbon 3. These two are the same. So I've done my 6 carbons across. I can then go down the line to 5 carbons and do 2 carbons coming off of different positions. I can have the 2 coming off of the same one there. They can come off of the same here. I have 4, so I can have 1, 2, 3, 4, 5, 6, 7. I can do a 5 carbon chain with 2 carbons coming off of there instead of just 2 single carbons. And I think that is it for those isomers. So there's quite a few different kinds that you can get through there. The next question, we are drawing the missing formal charge in each case below. So you might want to make a note to yourself of nitrogen likes to make 3 bonds with 1 lone pair. Oxygen like 2 bonds, 2 lone pairs. So if we stray from that, we're going to have a charge. In the first one, we have oxygen with 1 bond, which means it's going to have an extra electron pair. So that will be negative. Nitrogen's making 4 bonds, so this will be positive. And if you wanted to do the math for them, oxygen has a valence of 6. It's making 1 bond. And there are 6 electron lone pairs left over, so that makes that -1. Nitrogen is 5. It's making 4 bonds. There's 0 here, so this is +1. Nitrogen here has no formal charge, so there's nothing on that nitrogen because there is 1 lone pair, and it's making bonds to this carbon and 2 hydrogens. Oxygen here, so I can do the math for this one, 5. It's making 3 bonds. I have 2 lone pairs, so this is 0. Oxygen has 6. It's making 3 bonds. There's 1 lone pair. It's +1. 1 lone pair is 2 electrons, so that's +1. This oxygen is the same boat here, 3, 2. Nitrogen has 5. It's making 4 bonds. There's 0 electrons left over. This is +1. Okay, so here we're going to draw resonance structures. I'm just going to start at one spot. And the first observation, though, I'm going to make is where my sp3 carbons are. I'm just going to draw an X over top of them so I'm not tempted to draw electrons into those. So this is an sp3 carbon because there are no double bonds and there's no charge indicating that it's an sp2 that has an extra electron pair or is deficient one. And this one right here is also an sp3 carbon because there's no charges or double bond there. So I'm going to draw on a resonance structure here where the electrons go on to the oxygen. Here's another 7-membered ring. So all of the electrons in the ring are the same, but now I've shifted my electron lone pair onto the oxygen. So that has 3 pairs now, and this carbon is short a lone pair. The next resonance structure I can draw is going to be one where I shift electrons into this bond here. And remember that we can't put electrons here on the end or here. So I'm going to push this over to there. So these two are the same. My oxygen is still minus. The double bond is here now. And I've taken electrons out of this carbon over here, so this is now positively charged. All right, then I can take the next double bond and push those electrons here. And that's still going to be O minus. Double bond here, and then I have a double bond there, and my positive charge is there because that's where I took the electrons out. And then I can move electrons into there. And then I'll have a positive charge right there. That oxygen is still negative. So those would be the major or significant resonance structures for that compound. And you always want to keep checking when you're drawing these resonance structures that we're not putting electrons into sp3 carbons. All right, we have another resonance structure drawing. I have a positive charge. So this one indicates, because there's deficient an electron pair, this one is sp2. And the other sp3 carbons are here. This is sp3. This is sp3. This is sp3. So for my resonance, I can move these electrons from this sp2 double bond to form a bond there. So I have a double bond there. These two are the same. And my positive charge is now on this carbon right there, where I took the electrons out of. The next resonance structure I can draw is going to move these electrons in to form a double bond right there. My double bond will be here, so I've shifted the positive charge onto that carbon. And I can draw one more where these electrons go into here. I form a double bond here, and my positive charge is here. I can't move the electrons anymore where they're at, and that is because I have these sp3 carbons. That one is an sp3, so I can't push electrons in the other direction. The only thing that I could do here, if I wanted to get back to the original resonance structure, is to push these electrons, and you can do them all at the same time to get back to this resonance structure here. Okay, so this one is write a condensed structural formula for the following compound. So this is, we're removing the bonds, so it's not quite the Lewis structure with all the bonds in between. We're going to write a condensed structure. And there's a couple of different ways to do them. You could start with that chain and go CH3, and on there are two CH3s. And then we have CH2. There are two of those. So the two CH2s there. I have a CH, and then next to that is two CH3s. That would be one way. You could write out all of the CH2s if you wanted. And if I notice here, there's three CH3s on a C. I'm actually missing a C here. We'll squeeze in a C there. So we have C, CH3, so there should be 3, C, CH2, 2, CH, and then CH3, 2. So this one on top here should be CH3, 2, the CH3, a C, CH2, 2 of those, CH, and then CH3, 2. So there's two ways of, or there are two ways there of writing the condensed structural formula. And then here is a couple of more resonance structures. So one of them, I can just draw these electrons going around in the ring. And each time I take electrons out of a carbon, so let's say I take it out of that carbon right there to put it on the next one, that's going to force 5 bonds to carbon on this next carbon here. And so it keeps going around the ring, where that asterisk ends up with a positive charge, but then these electrons come around there. So that is what that one would look like. We can do a resonance structure where these electrons come in to form that double bond, and the electrons from this 5 bond is going to go on to, these will go on to that carbon. Sorry, that's kind of tiny there. So I've created a double bond here, which means my nitrogen is positively charged, and then I'll have a negative charge on this carbon. These can go on to form a bond between these two carbons, and then it will go on to that carbon right there. I'll have a double bond there, and then a minus charge on that carbon. And these can go in to form a double bond there, and those go on the end on that carbon. And there'll be a minus charge there. Okay, and all of those were atoms that could take the electrons or have them removed from their carbons or nitrogen. In this structure here for E, I have two sp2 carbons. I have two sp3 carbons on top that I can't put electrons into. But I can take the electrons from the end to form a double bond, and then these electrons will go onto the carbon. So I'll have the negative here. And the next structure, I can draw a bond forming there, and these electrons will go onto that carbon. So I form a double bond here, minus charge here, and then these can go here and go onto that carbon. And those are all of the resonance structures. For the last one, H here, the only places I can't put electrons are here, which I guess is a couple in there. Those are your sp3 carbons. So the first one here, I can take electrons out of this bond and put them into here. So that forms a double bond there, and now this is short a pair of electrons, so it's positive. I can move these electrons out of the ring into there. And then the electrons can come out of there. And we can actually get one more out of there. The electron lone pairs from the oxygen can go to form a bond there. And now oxygen is positively charged. All right, and those are the Chapter 2 problems. If you have other questions, feel free to send me an email. Thanks.